I'm going over the Chapter 4 practice test so you can understand how to do these problems. For number 1, you're just taking the cube root of negative 125, which is negative 5. It's pretty straightforward. For number 2, you're taking the cube root of negative 64 and then squaring that. So the cube root of negative 64 is negative 4, and you're going to square that, so you're going to get positive 16. For number 3, you're going to reduce 12 into 96 first. That will give you the cube root of 8, which is 2. If you rather go into primes and reduce that, that'll work as well. For number 4, you're going to add the two exponents. So 5/3 is 10/6 plus 1/6 to the negative 6. So when you add that, you get 3 to the 11/6 times negative 6, which is 3 to the negative 11, which is equal to 1 over 3 to the 11th, which is 1 over whatever 3 to the 11th is, which is 3. Let me put that on my calculator. 11 is 177,147. Make sure your fraction bar is long enough to cover all those numbers. For number 5, we're going to put everything into primes, or at least into multiples of 3. So 54 is 27 times 2. Then the exponents, I'm going to make those divisible by 3. So x to the 6th, y to the 3rd times y squared, z to the 9th times z squared. Then you can circle groups of 3, which are perfect cube roots. So the 3 will come out of the radical. We're going to have an x squared come out of the radical. Also, we're going to have a y and a z to the 3rd. And then in the radical, you're going to have a 2y squared, z squared. And that is a cube root, so don't forget the 3 there as well. For number 6, I'm going to distribute this negative 1/3 to everything. That's going to give me y to the negative 2/3. It's going to give me 27 to the negative 1/3. And then negative 1/3 times negative 6 is x squared. When I rewrite this, the x squared stays where it is because there's a positive exponent. The y moves to the denominator and becomes positive 2/3. And then 27 to the 1/3 moves up and becomes positive 1/3. 27 to the 1/3 in the numerator is 3 because that means the cube root of 27. And the denominator just stays exactly how it is. X squared, y to the 2/3. Make sure that looks like a exponent. For number 7, whenever you're adding or subtracting radicals, you must do them completely separately. So you have to keep them separate from each other. So that becomes 3 times 3 times 7. 112, if you divide that, you may divide that by 4, is 4 times 28. So that's going to be 2 times 2 times 2 times 2 times 7. Again, these are square roots. When you take out the number from in the radical to outside, you multiply by the coefficient that's already there. So you're going to get 15 square roots of 7 plus 4 times 2, so 8 square roots of 7. That gives you 23 square roots of 7.